Hello everyone, welcome to Pratibha Tech. In this video, we will solve the problem of the day question on Geeks for Geeks for 12th March 2023. The problem statement for today is binary matrix having maximum number of ones. This problem is based on binary search and algorithms and this has been asked in Swiggy interview. Let's open this problem now. First, we'll try to understand the given problem. Here it is said, given a binary matrix containing only 0 and 1 of order n into n. All the rows are sorted already. We need to find the row number with the maximum number of ones. Also find the number of ones in that row. Note, in case of type, print the smaller row number. Okay, row number should start from 0th index. Okay, so it is fine. So here it is simply said that will be provided with a binary matrix of order n into n, and here the important thing to take care is that all the rows are already sorted. So it will be started with the 0 and the later on the ones will be coming in. So we have to find the row number which contains the maximum number of ones, and we have to return that row number as well. So actually this is a very simple question. So if we look at this given example, then here it is said that matrix size is 3 into 3. So this is the given matrix. So here the row number 1 contains maximum number of ones, that is count 2. This row. This is the row number 1 with maximum count of ones as 2. So here the maximum number of ones is in the row number 1 and this count is 2. For a second example, if you see, so here it is given the matrix this way with size 3 into 3. So here row number 1 and row number 2, that means if we are talking in 0th index, then row number 0 and row number 1 both are containing all ones. So here if you look at this note, in case of type, print the smaller row number. So we have to consider the first one, this is first one. So here the row number is 0 and maximum count of ones is 3. So this is the simple answer. So to understand it better, to approach this one, actually we will be solving this problem in two approaches. Okay, so let's go to canvas to better understand the approaches. So here what we'll do, since it is given that the array is already sorted, so here we can see if we traverse it column wise, that means in this direction, if we traverse in column wise, so the row number where we encounter the first row, where we encounter the first one, we can simply return that answer. I hope this is clear. So initially we will be traveling this complete column, no ones is encountered. Then we are in the next iteration we are traversing this column. Then here we see for this row, for this I is equal to 1, that means row number 1, we have encountered the first one. So since it is sorted, then we can say that this is that largest one, this is the row number which contains the largest number of ones. So we can simply return that row number and with that count starting from here to n. So it is that simple because it is given, it is already sorted. So instead of traversing row wise, we will be traversing column wise, and we'll just see which row contains the first one. So we can simply return that one. I hope this point is very easy to understand and this is very clear. So let's try to solve this with this approach. So I've just prepared the solution. I'll just copy it. This one. So here what we have done, here it is this, the solution is this much only. Here we are starting from I is equal to 0 to n and j is again also from 0 to n, and here we are checking matrix of j and I, not ij. Here it is revolta or the reverse one. Matrix of ji is equal to 1. That means for each row we will be for row number 0 we will be looking at all the columns. That means for row 0 we will be looking at all the columns. Row 0 means when it will be in this one, I is equal to, it will be pointing to 0, we will be looking at all the columns. I hope this is clear. So when we do ij, matrix of ij, then we look at all the columns of this row. Now we are doing matrix of ji. So here the row number is changing, but column number is remaining same. So here we are first looking at this row, and this row for the first column only. That's why that in that ulta is being done, the opposite is done here. Matrix of ji is equal to 1. Wherever we encounter the first one, we simply return that row number and the count n minus I. And in case we do not encounter any one, then we simply return 0 0. So let's try compiling this approach. Let's try submitting this solution. So here you can see the approach which we discussed, the first approach, that has worked perfectly fine for us. So here let's go to canvas again, and if we look at this example also, so here we can see this is the second example given in the problem. So here we can see in the first row or first column there only we encountered the first one. So we simply return this row number with the number of ones is equal to the total size of this particular row. I hope this is clear. So this was our first approach. Now in second approach, what we'll do, let me just clear this. So in the second approach, what we'll do, we will start from rightmost element in the first row of the matrix and moves towards the left until the first occurrence of 1 is found. Once a 1 is found, we move down to the next row and repeat the same process. But we start moving towards the left from the column index from where we found the first occurrence of where we found the first one in the previous row. We will continue this process until we reach to the last row of the matrix. So here what we'll do, we'll start from rightmost element of the first row. So this is the rightmost element of the first row, and if you have 1 is encountered, then we will keep moving towards the left. Okay, so here we can see here it is 0 is encountered, so it will break the heap from here and it will just return here. For the first time we will be set that row value as this one 0 and count value as 1. Now in the next iteration we will see again, here it will start again, and here we will see again the way we tried in the first row, we will even try in the second row, that if 1 is encountered, then we move towards the left until the first occurrence of 1 is found. So first occurrence in this row, in this particular row, where is the first occurrence of 1? This is the first occurrence of 1. So we continue to move towards this one, and if we reach to the first occurrence of 1, and then we will see if this whatever we are getting there, the count and the row number, that means simply the most important thing is the count here. If the count in the next row where we have encountered the first one, is it greater than the previous one? If it is greater than the previous one, then we will simply update the row. We will update the row count and the number of ones there. So it is that easy. I'll try to explain it again. The approach we will be using here is to start from the rightmost element in the first row of the matrix and move towards the left until first occurrence of 1 is found. Once a 1 is found, we move down to the next row and repeat the same process. But we start moving towards the left from the column index where we found the first occurrence in the previous row. We continue this process until we reach the last row of the matrix. And we keep updating the value. So even I have prepared this solution. Same thing we can apply it here. If we start from this one, then we continue moving left till the point we reach where the first occurrence of 1 is found. So this is the one, and in the next iteration here also we can see all ones are there. So if we try the same thing here, but here we can see if we try to compare the count, then the count in the current row is not greater than the count in the previous row. That's why we will not update that row number or the row count. If it is greater, if it is suppose one more 0 was here and one more 1 was here, and here also 0, then then we could have updated that row count and row number. But since the count is still the same, so as it was said in the question, that go with the smaller one here. In case of type, print the smaller row number. So that's why if it is greater than only, then only we'll update, else we will not update. So even I prepared this solution. So now let's try seeing this, what we are doing in this one. So I'll just replace. This is our second approach to solve this question. This is the thing here. I have like other solutions, I have also tried giving some comments here so that it becomes self-explanatory. Okay, so here what we are doing, we are initializing two variables, max count and max row to 0 0. Start from the rightmost element in the first row of the matrix and move towards the left until the first occurrence of 1 is found. Store the column index of the first one in the variable called j. I hope this is clear. Then we set max count to the number of ones in the first row and max row to 1. For each row, starting from the second row of the matrix, move towards the left, starting from the column index j until the first occurrence of 1 is found. If a 1 is found, update j to the new column index and update max count and max row if the number of ones in the current row is greater than the max count. This line we have to take care of, so that's why I have also written here. So here, if you are saying that if this is lower than, if the current row has less number of rows than the maximum we have seen so far, then we are just breaking from that loop. Okay, if it is not that thing, then we will continue moving towards the left until the first one is encountered, and for that we will keep decrementing the value of j so that we reach towards the start of that row. And whenever that is done, that means here if you look at this one, so here it will be something, j will be 2, then j will be 1. So here we say if the current row has more, if you are looking at this one, if the current row has more ones than the maximum we have seen so far, update max row and max count. So that only we have done here. I hope this is clear. So yes, it is greater because now we have encountered 2 ones here. That means this one, the j value is smaller. Since we are starting from the rightmost and we keep decreasing the value of j upon encountering one in that row. So that's why n minus j, it will give a bigger number. I hope this is very clear. So now this value will be greater than max count. Then we update max row as the I as a new row, and max count is the same value. That means the number of ones encountered. Okay. After traversing all the rows, max row will contain row number with the maximum number of ones, and max count will contain the number of ones in that row. Return the array with max row and max count as the 2 elements. So that we are doing here. We are simply returning. So this was our second approach. Now let's try compiling this approach. So here we can see this given example works fine for it. Now let's try submitting the second approach solution. So here we can see even the second approach has worked fine for us, and this all the test cases it has cleared, and this problem has been solved successfully. So talking about the time complexity of this algorithm, it is a big O of n square, where n is the size of the matrix. This is because we need to traverse each element in the worst case. However, in practice, the time complexity will be less than big O of n square because we stop traversing a row as soon as we find a 1 in that row. So we do not need to traverse all columns of each row. And if it is 0, then we are completely leaving. If the rightmost element itself is 0, then we completely ignoring that particular row itself. So in practice, it will be way less than n square. Actually, it will be we won't be even traversing the half of the all the elements given there. So I hope these two approaches were very clear. I'll provide the link for this question in the description box. Please do check that. That's all in this video. Please like, comment and share the video, and please subscribe to the channel for more upcoming videos. Thank you for watching.